guys. Today we have a pretty easy section, mainly because it's really not a lot of new stuff we've already done. 5-2 polynomials, linear factors, and zeros. Oh my. Right? Like lions, tigers, and bears. Oh my. Huh? Yeah? Oh, see, I was funny. And I love my little mummy guy because he just makes me smile. So he's on every page because he's really cute. So for today, we're going to factor a polynomial. Have we factored before? Yeah, we sure have. We're going to find the zeros in factored form. Have we done that before? Yep, sure have. And we're going to write a polynomial function from its zeros. That we've not done. So that is really the only new part today. Okay? So it shouldn't be too bad. All right, so first thing, solving a polynomial by factoring. We've already done this. So the only difference is normally we write them equal to 0, standard form equal to 0, and then we factor. Now they're going to be written as y equals in the equations. Mainly, it's the same idea. We're looking at when my y value is 0, what is my answer? So it's going to be set equal to y. When we graph things, it's always y equals and then your equation that we graph. We're going to graph a lot in this chapter. So don't be alarmed when you see the y equals, same idea. Okay? So we're going to factor. What's the first thing I do to factor this? Take out an x. So if I factor out an x, we have x squared minus 2x minus 15. And if you want to put the 0 in there because it makes you more comfortable, by all means, because I will probably always write it with a 0. All right, because really that's what we're doing. What does x equal? My y value is 0. Same idea. Okay, so we're going to factor that further. My last one's negative. My signs are different, opposite, good. X squared, just x and x. 3 plus 3 minus 5, I want negative 2. So then what does x equal?
5, -3.
And? There you go. So 0, negative 3, and 5. I've mentioned you guys numerous times that your highest exponent is how many answers you should have. We've only done x squared, so we've always had 2 answers. Now, that problem has an exponent of 3. So you should have 3 answers. So 0, negative 3, and 5. Look at that. More answers than you ever had before. Was it that bad? Yeah? All right. So find the zeros of the function, and then sketch the graph. Oh, we learned about graphs yesterday, right? Just like, the look on your face is like, wait, what? There are squiggles and smileys and frowny faces. That's all right. We'll catch you back up. Poor Jared. All right, so find the zeros. So same idea what we just did. Anytime you see the word find the zeros, all we're really doing is setting it equal to 0 and solve. That's all we're doing. Okay, so throughout this chapter, you see that a lot. Find the zeros. What are the zeros of something? It just means set it equal to 0, solve it for me. All right, so 0 equals. Good, take out an x. So x squared plus 3x minus 10. What did you say? X plus 5. Good. So x equals 0 to negative 5. All right. So what all this means, and as we get more and more into this chapter, we'll look a lot at graphs. The answers are where it's crossing the x-axis, right? So if it says x equals 0, that means it will cross the x-axis at 0. X equals 2, it's going to cross again at 2. And negative 5, it's going to cross again at negative 5. So if I look at its graph, I can actually know its answers without even solving anything. I can look at the graph. So what does the graph kind of look like? Well, let's talk about what we learned yesterday, right? That's assuming what you're going from. So if it's an odd exponent, is it squiggly or smiley frown? Squiggly. And it's positive, so it's squiggly up. It should look like this. Something like that. So we know it's going to go up. I totally almost missed them. So up, it's going to come down, and it's going to come back up again. What part of that did I guess on, though? Yeah, do I know how high it really goes or how low it goes? I have no idea. But I can get a rough idea of kind of what it looks like. Pretty cool, right? All right, so find the zeros of each function. In other words, set it equal to 0 and solve it. Notice it doesn't say solve by factoring, right? But at this moment, think about we learned 4 different methods. So could you use the square root method? No. Do you just have an x squared? No, I got an x cubed in there. I can't do square root method on a cube. All right, completing the square. Nope. Quadratic formula. Does that solve everything? Only quadratics, which is an x squared. So if I'm with an x cubed, factoring is the only option I have right now. Yeah. We'll learn other options, but really it all comes down to, can I turn it into a quadratic so then I can use something I know? Yes. Yes, there are. All right, so here we go. So we're going to set it equal to 0. I can take out an x. Did we factor it from there? What? Very nice. Good factoring. So then x equals. Alex is the only one talking to me. The rest of you guys okay? He is quick. Thank you. All right, how about number 4? What can I do to factor that one? Very good. What do I have left? Plus what? Good. We have an x squared, so we better try to factor that further. 2x and x. Plus minus. 1 and 5, 5 and 1. 1 and 5. Are my signs good, or do they need to switch? They need to switch. Have you found that your factoring's gotten a little faster, though? The more we do it, it gets a little better. All right, so what does x equal? Beautiful. Well, it worked out. It was still 0, yeah. Yeah, when you set 2x equal to 0, still 0. Yeah, so don't panic. That you did it right. Yes. If you pulled out an x, yeah. Yeah. Yep. Ooh, number 5. How many answers will I find? 4 answers. There are. It's x to the 4th. So I should find 4 answers. Yes, it's necessary. It's so much fun. You get 4 answers. Yay! Good. I can take out a 3x squared. That doesn't make it so hard then. So what do you got left? My 3 looks funny. That's fancy. All right, so let's factor the rest of it. X minus. Both my signs are minuses. 9 and 7, 7 and 9. What does x equal? You're right, 7 and 9. Well, technically we're setting this equal to 0, right? Divide by 3. So x squared equals 0. Take the square root. So x equals plus or minus 0. But it's technically it's two answers, right? Okay. Normally, like if it was the same answer that showed up twice, did we ever list it twice? We really didn't. You don't have to here. Me personally, like we're okay to technically this is two answers, right? So me personally, I'll list it twice. That way my brain sees that and says I do have four answers. Because otherwise it freaks me out. I'm like, oh my god, I missed an answer. There's only three of them written there. If you only write it once, that's fine. I'm not going to count off for that. Okay. But me personally, I like to see four out there since I know there should be four. On today, where we're factoring, yes. In the future, no. Yeah, we're baby stepping through this, right? We're going to get through eventually the harder stuff. All right, you guys want to go ahead and try number 6? All right, number 6. All right, number 6. What did you do first? 0 equals, what'd you take out? So 3x squared. Good. Factor further. Good. So x equals? I like to list 0 twice because I'm weird like that. And then -4/3. But this is definitely, guys, the chapter where you're going to want to double check. My problems start with x to the 4th. Do I have 4 answers? Okay. Make sure I was doing that little mental check. Sometimes you just forget. No. If I had taken out 3x to the 3rd, I'd have 3 zeros. I'd have 3 zeros. It'd be like 0, 0, 0. Then. Yeah, if that's out in front. Yeah. All right. So now let's kind of do the reverse. If I give you the answers, can you go back and tell me what the original problem was? But you will in a minute. All right, so what is a cubic polynomial function? So cubic, it's going to be an x to the 3rd. So how many answers should you have? They gave me 3. With the zeros, meaning when I set it equal to 0 and solve, this is what I got, right? So these are my answers. So don't get hung up on the word zeros. -3, 3, and 4. Do you want to see how easy this really is? It's really not that bad. It's going to be y equals, right? We're writing an equation. If you got the answer of -3, what parenthesis did it come out of? Came out of x plus 3. Where did 3 come from? X minus 3. Where did 4 come from? X minus 4. Are you with me so far? Right? We normally just take the opposite when we take them in and out. So first thing, step 1, write a factor for each 0. The sign within your factor will be the opposite of the sign of the 0. This is exactly what we did. -3 came from here, right? If I set this equal to 0 and solve, x equals -3. So we're just writing these back out. You can multiply truly in any order, right? Doesn't matter. We can multiply the first 2, and then by the 3rd one, or the last 2, and then by the first one. Or I can do the first and the last, and then multiply by the middle one. Doesn't matter. Me personally, I start at the back and kind of work my way to the front. Just me personally, you don't have to do it that way. I always start in the back. So I'm going to multiply these back 2 together. I use the word FOIL here. I hate that word. You know, that's like a profanity to me. Distribute. But when I write distribute, people go, distribute how? Like they suddenly don't know what they're doing. So I use the word FOIL just so you know what I'm talking about. Lobster claw it. Lobster claw. So we're just going to multiply this together. So we get x squared minus 4x minus 3x plus 12. Put my like terms together. X squared minus 7x plus 12. So at this point, I just multiplied the last 2 together. Are you okay with that? And now, which one have I not multiplied yet? First one. So I'm just going to drop that one down. And now I need to multiply those together. Any idea why I start in the back? Because when I multiply those first two together, you end up with a trinomial. And then I'm going to multiply it by a binomial. And for whatever reason, I don't like the 3 of terms in front and the 2 terms on the back. It just looks awkward when I try to distribute. X squared minus 9. Yeah. In this case, yeah, you could have done that. Jesse? What do you mean? Oh, okay, let's take it back to regular numbers for a minute. If I asked you to multiply 3 times 4 times 5, how would you multiply that? No, your brain doesn't multiply them all at the same time. How do you multiply them? She did 4 times 5, and then she took that answer of 20 and multiplied it by the 3, right? Makes it easier. Right, but could I have multiplied 3 times 4 and gotten 12 and then multiplied by 5? Would you ever dream of distributing the 3? That's just weird, right? So you wouldn't distribute this into everything because that's weird. Yeah, you multiply 2 of them together and then take that answer and multiply by the other one. So now I multiplied those two and got this. Now I need to bring this one down. We're going to multiply again. So we get x cubed minus 7x squared plus 12x plus 3x squared. These are tedious more than anything else. Minus 21x plus 36. So y equals x cubed minus 4x squared minus 9x plus 36. Do you notice how I kind of lined up my work as I multiplied through that? It gets to be helpful. That way I kind of line up my like terms. You don't have to. Some people like the, I'm just going to put all on a line method and then find it. And that's fine. You can do that. For me, it's just easier as I get multiplying to kind of line it up, and then it's faster to put together. Sure. Let's try another one. So number 8. What is a cubic polynomial function with zeros -5, 0, and 2? So we're going to write y equals, because I'm writing my equation. Where does -5 come from? Comes from x plus 5. Where does 0 come from?
Oh, it comes the GCF.
The GCF of x that you always pulled out in front?
Yeah.
I like when there's zeros, because that's just an x out in front. And where does 2 come from? X minus 2. Make sure you're saying x minus 2, not just -2. Okay? Again, you can start by multiplying whatever 2 you want. Me personally, I like to start in the back. So I'm going to multiply these two together. X squared minus 2x plus 5x minus 10. Like terms, x squared plus 3x minus 10. Right? I just multiplied 2 of them. This one I haven't used yet. I'm going to bring it down, and now I'm going to multiply through by that one. Right? So y equals x cubed plus 3x squared minus 10x. And it told you it was cubic. Did you end up with x cubed? Yeah, we did. Look at the next one. Quartic is 4. So how many things am I going to have to multiply together? 4. 4. Sure. Hold on a sec. Hold that thought. Because you just said what a lot of people do, which is wrong. So I want to talk about that. All right, where does negative 4 come from? X plus 4. Negative 3? 1? 4? Oh, good. We at least got the first part done, right? Got it. Put them all in there. All right, now, Alex, he said something, which is what most students do, which is incorrect. Let's say I'm going to ask you to multiply 1 times 2 times 3 times 4. The question was, can I multiply these two together? Sure, 12. And the first two together, 2. He said, and then add them.
No, I meant add them.
You said add. Most students will do that, though. What do I do with those? You got to multiply them.
So the answer to my question is yes.
Well, the way you worded it, no. But if that's what you meant. Okay. We're good? We're clear?
Yeah, lobster claw the two ends, and lobster claw the two answers.
Yes. Yes. All right. Usually, though, when we see it in regular numbers, it makes a little more sense, like what we're doing with this. So, lobster claw the front and lobster claw the back. By default, I always lobster claw the back first, so I'm going to start there. Yes, you could. All right. So here we go. So I'm going to go x squared minus 4x minus 1x plus 4. So x squared minus 5x plus 4. All right, so you're going to multiply the back two, multiply the front two. Lobster claw. So x squared plus 3x plus 4x plus 12. I ran out of space. So x squared plus 7x plus 12. All right, so there's the first part, right? Multiply the back two, multiply the front two. What do you do with both of those? You multiply them together. A lot of students will do that. Like, they're doing great to here, and then they decide, I'm just going to add it all together. That's not how we're trying to multiply. So how fun is this multiplication going to be? See why I hate the word FOIL? FOIL doesn't work here. I need a 6-letter word to make this one work. All right, here we go. Whew. So we get x to the 4th minus 5x cubed plus 4x squared plus 7x cubed minus 35x squared plus 28x plus 12x squared minus 60x plus 48. And again, if I do it correctly, I can line up my like terms instead of this huge line of stuff. Yeah, it lines up a lot nicer. Hey, Colton. All right, what do I do with all this then?
Add like terms?
Add like terms. So y equals, we get x to the 4th. What do we got? Plus 2x cubed. There's a lot going on in here.
There's so many.
4 minus 35 is negative 31 plus 12. Is that 19? Negative 19. X squared. The brain doesn't work as well here in the afternoon. 28 minus 60. That's negative 32. X plus 48. What happens if you miss one negative sign? Yeah, pretty much. It's all wrong. So these type of problems, hard or just tedious? They're just long and tedious. And if you miss one sign, long division will be coming. What? Totally fine. Did you get the same answer? Did something wrong. Long division is in chapter 5. Yeah. There's some weird ways for long division. But we're doing long division with polynomials. So my guess is you're going to want to do it the way I teach you. Then I'll teach you synthetic division.
Oh boy.
That's fun. I really like synthetic division. It is so fast. It's like 10 times faster than anything else of division. Because you can't do everything with synthetic division. Some of them you have to go back to long division. I don't know why it's called synthetic. It's a good question. I don't know. I don't know. All right. You guys want to try 2 on your own? Yes, you do. I knew you'd be excited. Go ahead and try 10 and 11 for me, please. Okay, 10 and 11. All right, so 10 and 11. How do we do? Yay? Nay? Good? Yay? Jared? Yay? You look all brainiac-ish with those glasses on. Is that a word? Brainiac-ish? Sure. It's like one of my A block, they were like shooting baskets with trash, you know, like rotted up pieces of paper. I'm like, fine if you want to shoot it. I'm like, but if you miss, it's 10 push-ups. And they're like, but if I make it, can I get candy? I'm like, sure, why not? So they're like, wasted a whole lot of time yesterday, like shooting. And one kid, he's like, he had to do like 30 push-ups because he kept missing. And he's in here, and like other students are like these beautiful push-ups, straight up and down, like beautiful, because you know they're all in like public safety and all of that. So was this kid, and they were like 1-ish, 2-ish, like his butt was in the air, like his head was moving, but like his arms weren't. You know what I mean? Like one of those push-ups. Yeah, it was like one of those. So I'm like 1-ish, 2-ish. Yeah, it was pretty funny. He was a good sport about me teasing him though. All right, so here we go. The other part of this we've actually already kind of talked about is repeated zeros or double solutions. So what are the zeros of that? It's already in factored form. So what would you tell me the zeros are or the answers are here? 3 and 3. So how many times is 3 a 0? Twice. Now, this will actually come into play when we start looking at graphs, because how would you recognize looking at a graph that 3 shows up twice? When you're trying to like figure out how many answers you can find on the graph, how do you recognize that? Let's look at the graph of this. It's actually pretty interesting. All right, so we found out what happens when an answer shows up twice. What's the graph look like? What happens? Does it go through the x-axis? No, it touches it. Only touches one time and then goes back up. And then the other one actually went like down here, right? That's a terrible graph. But it crossed at 1.5, and then since 3 showed up twice, it just touched it and went back up. Did you lose your balloon? Oh, your pencil. Anthony's not here. I don't expect these shenanigans without Anthony and Seth. Shenanigans. It's a good word, isn't it? It's the word of the day. Make sure you use it sometime today. Shenanigans. All right, 13. What are the zeros of that? How do I find the zeros? I factor. At this point, all we know how to do with something like that is factor it. So your GCF? So x squared minus 6x plus 9. How does that factor? Good, x minus 3 squared. So x equals that's only 3 answers. There's actually 2 zeros, right? It's because it's x squared. It was implied. So yeah, you should have 4 answers. 0 shows up twice. 3 shows up twice. Can you have an idea what that graph looks like? Even without, I could draw a rough sketch of this. Right? What's your end behavior? What does it look like? Smiley, frowny, squiggly. Smiley, smiley, right? Even exponent positive.
Oh yeah, it's like it's separated. It would go, right? It's separated.
It looks like a W, right? Because it's supposed to hit it at 0 and 3, and it should be a smiley face end behavior. So it's going to come down. It's probably going to come up some, and then it's going to come back down again. Looks like a W type thing.
What?
Moving on. All right. Remember we talked though about end behaviors, just the ends. The middle, remember we talked about, because Jared was like, why do these all look the same? As you start changing it, you get more and more curves and everything in between there. Remember we talked about turning points, right? How many turning points does this have? 1, 2, 3. Turning points plus 1 would be my degree, so my degree is 4. Okay? Starting to make sense, right? It's all coming together. It looks like a cell phone, like you're going to take a picture. How close were we on the graph? It could look slightly different. See, did you guys graph it?
Oh,
So, is in between here? Does it go higher or lower? It goes higher. I don't know. I didn't graph it. Oh, okay. Yeah, it wasn't bad. So really, it's like up in here. We were pretty close, though, right? That's not bad. Impressive. And that was without a calculator. Thank you very much. I'll be here all day. All right. Questions on anything we did today? Really, we factored, and then we learned how to foil. Lobster claw. Lobster claw. Distribute. He got all mathematical on me back there. Distribute. All right. We aren't going to talk about all this stuff right now. So your assignments, page 293, 8 to 34 even. But before we do that, we need a little fun, right? Yeah.